Let's wrap up this mitigation potential in the forest sector. I'm going to come back to this natural climate solutions again at the end, but I wanted to just put it in here also to look at the various options that are listed under natural climate solutions. We'll look at a little bit more detail later on. And they include the terrestrial biosphere, which we are looking at, especially forests, a sector that we are considering right now. So reforestation, avoided forest conversion, trees in agricultural lands, what is called agroforestry, which has tremendous benefits in terms of soil moisture persistence increasing, groundwater recharge, reducing evaporation losses, income after the rainy seasons if the trees are properly used, drought resilience, carbon sequestration, and so on. Improved natural forest management, biochar, we will look at that, reduced wood fuel harvest, nutrient management, and so on. So you can see the various mitigation potentials here. So this is very critical. Implementation is basically possible under the so-called nationally determined contributions as well, and can be combined with socioeconomic indicators for tracking progress, additional carbon sequestration, ecological indicators, and carbon pricing program. Okay, so moving on then to the mitigation potential in the, oops, I missed one slide there. Under forest sector, we also have to worry about how the forest management is going to assist mitigation by the forest as well. And one of the big factors there is management of the harvested wood biomass. It's really great if we can have a forest that's completely protected and not exploited in any way, but we know that that's not very easy at all. Only when there is really protected species like some primates or certain animals living there, then it becomes better protected in terms of harvesting for biomass. But even there, ecotourism is kind of a human impact that has to be watched out for, right? So this is a schematic of how to worry about management of harvested wood biomass to make sure that the forest sector mitigation is not diminished by this activity. So looking again at the Earth system perspective and the feedbacks, we are looking here at harvested wood. Wood energy, wood products, landfills, these are the kind of sectors into which this carbon cycle has to be tracked. And then you have, of course, the feedbacks between live vegetation and atmosphere, and vegetation and standing dead vegetation. So basically carbon sequestration and its persistence, the stock that remains undisturbed. You have to always keep in mind that as great as forests are for carbon sequestration, protecting them from disturbances, even avoiding as much as possible various human activities that tend to degrade forests, other than just deforestation for agriculture and development and so on. Those are critical. So standing dead vegetation, down wood and forest floor, and into the soil, matter into the soil. So all these things have to be managed in a sustainable way. There are many such studies that show about how to also account for transportation and other activities that kind of are part of the life cycle analysis, for example. And we'll come back to that when we look at monitoring, verification, and reporting under the Paris Agreement for the commitments that the countries make. For example, India and China have afforestation and reduced deforestation as part of their nationally determined contributions to creating additional carbon sinks. So there the reporting and verification becomes critical. So finally, mitigation potential in the agriculture sector. These are examples of agricultural management actions that can increase organic carbon storage and promote a net removal of CO2 from the atmosphere. Here, soil organic carbon balance is obviously the main factor. There is always the Earth system feedback in terms of warming soil moisture loss, increased microbial activities, increased respiration, and so on, that we have to worry about in the full carbon cycle analysis. So management practices include improved crop rotations, increased crop residues, so allowing the biomass to get converted back into carbon and nutrients into the soil. Cover crops, so that between two major crops you have a cover crop like legumes, which can sequester nitrogen or capture fixed nitrogen into the soils, which is very important for nutrient balance, nutrient enhancement, reducing soil erosion, etc. Conversion to perennial grasses and legumes where possible, instead of having the rotation of crops every year or multiple times a year. Perennial crops and legumes, again, as nitrogen fixers, are going to be beneficial. Manure and compost addition, so biomass can be converted to manure and compost and used as fertilizer, natural fertilizer, and improve soil health and functionality. No tillage and other conservation tillage. So tillage is a big impact on exposing soil to carbon losses. So and it's also bad for soil quality, soil health, because you're removing biomass there as well. Re-wetting organic i.e. peat and muck soils, we will come back to biochar as well, and improved grazing land management. So it's livestock is not just a source of methane, but they are also, if not managed properly, can degrade land during grazing, depending on how they pull out the grass and leave. So you have to move the cattle for the vegetation to recover after it has been intensely grazed for some time. And when you have massive amount of cattle that are concentrated in a farm, this is something that becomes critical. So looking at abatement cost in terms of abatement potential, basically we need a concept of marginal cost and abatement cost here. Abatement cost is the cost of reducing environmental negatives like pollution or emission of greenhouse gases. Marginal cost is an additional concept in economics which basically says how much does it cost for an additional unit of action of reducing, let's say, greenhouse gases or nutrient pollution into the groundwater, etc. So marginal abatement cost in general measures the cost of reducing one more unit of pollution or greenhouse gas. Okay, so when the abatement cost is negative, this is the cost to GDP, which means the co-benefits or the direct benefits are actually already profitable if we do this. And those include things like cropland nutrient management, tillage and residue management that we just talked about as a mitigation potential for agricultural land, grassland nutrient management, rice and nutrient management. So rice is a big staple diet for billions, and the way it's cultivated predominantly with flood irrigation is a huge source of methane, so that's an easy target as well. Rice management and shallow flooding instead of the deep flooding. Basically it's done to get rid of the weeds, and there is plenty of evidence that other approaches like the Madagascar rice can be done without flooding, and can be even done on rooftops and so on. So reducing methane, which has a high global warming potential, obviously is very beneficial. So those are negative costs here, with plenty of abatement potential in terms of million tons of CO2 equivalent per year. So this is cost in euros per ton of CO2 equivalent, and on this axis we have the amount of carbon that can be avoided from emission into the atmosphere. Here you have some with positive costs, grassland management. So grassland nutrient management and grassland management here are separated. I'm not going to go into the details, but you can follow up if that's your field of interest. Organic soil restoration for soil health and functionality. Degraded land restoration. I don't know why this spelling mistake is there. agronomy practice, and livestock feed supplements. Okay, so this is just an indication that there is much thought already given to the abatement cost and the sequestration potential in agricultural lands. Looking at potential global contributions of response options to mitigation, adaptation, and combating desertification and land degradation, as well as enhancing food security as a co-benefit. Agriculture is in here. Already we looked at forests, soils, I mentioned, and other ecosystems. So response options based on land management and response option based on value chain management. So this is not exactly a life cycle analysis, but it's a agroeconomic or economic analysis of the response options as well. So increased food productivity, agroforestry, which I mentioned already, with many beneficial effects, improved cropland management, so some of the options we already saw, agricultural diversification, improved grazing land management, and so on. And under forests you have, of course, management and reduced deforestation and forest degradation, or RED, which is a program under UNFCCC as well. Increased soil organic carbon content, reduce soil erosion, salinization, compaction, and other ecosystems like fire management, reduce landslides and natural hazards, etc. So the response options that rely on additional land use change also include bioenergy and BECCS, which we'll come back to, reforestation and forest restoration, afforestation, and biochar addition to soils, which I will come back to. So in terms of value chain management, we have to look at demand and supply, which is the favorite thing for economists, and of course risks. They always talk about return on investments, which essentially means what are the risks involved in investing in those economic activities like value chain management. So reduced post-harvest losses in terms of managing demand, dietary change, huge factor, but involves a lot of cultural values, behavioral values, just personal preferences. I love fish, for example, can easily live without meat. I've grown up vegetarian. Reduce food waste, consumer and retailer, sustainable sourcing of supplies, improved food processing and retailing, improved energy use in food systems, and under risks you have livelihood diversification that is needed just to deal with droughts, impacts of warming on, let's say, dairy production, for example, management of urban sprawl, which always infringes on rural areas and agricultural land and supply chain values, and risk sharing instruments like crop insurance or subsidies of various types that often have to be removed to reduce risk. Let's say subsidizing irrigation or energy use for irrigation is a risk for water resource management, so reducing subsidies there can actually reduce the risk on water resources. Okay, so we'll come back to bioenergy sector. Obviously we are just giving brief introduction to mitigation potential in these sectors. As always, this is kind of a survey, so you have to follow up on the details based on your particular interest, research, or otherwise action, hopefully as well, and you can do that.